Hi, today I'd like to show you some of the work that my colleagues and I have been doing on a system for building user interfaces following a 2.5 view paradigm. One view is a graphics direct manipulation editor. A second view is a text editor containing a textual description of the user interface in a, quote, little language. And the third view is a result view showing the user interface exactly how it's going to look at runtime. We believe that the system combines the virtues of interactive direct manipulation systems with that of textual programming systems and does not suffer the liabilities inherent in either. Let's now take a look at the system in action. The result view is in the upper right-hand corner. This shows the user interface pretty much the way it's going to look at runtime to the end user. Right now it's watching our keystrokes and responding to it the same way that the user interface will respond at runtime. Below that we have the graphics view. It shows an exploded version of our user interface, making visible all of the hidden structure, such as horizontal groupers, as well as vertical groupers. Above that, to the left, we have the text view, and this is just a simple text editor. And in fact, why don't we now copy one of the choices that we had for printer qualities, copy the high resolution choice, and let's make it a medium resolution. Now, nothing is changing inside the graphics view or the result view yet. However, when I hit the reparse button, both views will be updated with the new option. And let me now, in the text editor, just pretty print. Okay. Well, that's fine, except medium, high, low is not quite the order I'd like. So let me grab the low resolution option and just drag him and place him right down here. Okay, now if you look in the text view also changed to reflect that editing action. If I hit the pretty printer, we can see a little bit clearer that we have low, medium, then high options. Going back to the graphics view, I could create a new choice by picking up an existing choice, bringing him to our copier, and taking him from the copier and pasting him in. Or alternatively, I could build up the interactor from scratch. I'll take a text interactor. I'll call him poor resolution. And what I'm really going to want to do is I'm going to want to have a bitmap next to it. So let me nest the poor resolution with a horizontal box. And now I can take a bitmap and put him in there. And spade very low res. And if you notice, the text view and the result view are constantly being updated after each action in the graphics view. And let me now surround that with a choice option. And we're set. Okay, if we look inside the result view, sure enough, we have the choice that we just created, the poor resolution, the low resolution choice that we had gotten from copying within the graphics view, this low resolution choice that we got from copying in the text view, and our two original choices, the medium and the high. Let's now put a border around our printer quality options in the original example. And I'll double click now and bring up a set of properties for that border. I'll make it blue and make it nice and thick so we can really see it. And sure enough. Let me bring up that property form again. And at the bottom here we have properties that are inherited by all of the descendants in this hierarchical arrangement of components. So if I make a background color of wheat and put a font of L12B, although the border doesn't have a background color or a font, all of its children do have background colors and fonts, and sure enough, they inherited those attributes. We could actually take any interactor and give it inheritable attributes. So what I'm going to do over here is, to make it noticeable, I'll make a nice bright green background color. And this whole region over here will become green, except for parts in the hierarchy that have overridden the inheritable properties, such as the border over here. If I were to take the border out and, say, bring him down over here, then we see that the inheritable attributes, sure enough, get inherited appropriately. And if we take a step back, we see in the result view the various colors and fonts where we expect them, and in the text view, after I pretty print it, we see, sure enough, that the changes have been echoed here. Let's go back to our original example and see what happens as the result view changes its size. The OK and Cancel buttons stay centered on the 1/3 and 2/3 lines. This is because there's some filler both to their sides and between them, and following text boxes and glue paradigm, any extra space is spread out evenly into these fillers. Let's add a new button, which we happen to have in the paste buffer. And now let's add some fillers to the between the OK and Revert, and between the Revert and Cancel. And sure enough, as the window changes sizes, these three buttons are always going to be exactly evenly spaced. Unlike Tech, where only boxes can have stretchability, in FormsVBT, any interactor can have stretchability. By default, our buttons have a width of size 60, and what I'll do for the Revert button is give it some infinite stretchability also. Now, as the window gets larger or smaller, the extra space is divided not only into the 4 filler regions, but also into the center Revert button. The last topic I want to briefly touch upon is extensibility. Window classes in our underlying environment are very easy to incorporate into FormsVBT, and most can be done so without changing any of the runtime or graphics editor source codes. Here's the result view running with some of the pieces we've incorporated. We have overlapping windows, and these windows themselves are showing images of a variety of flavors. One of the images is serving as the base of a pull-down menu, which is bringing up a little form over here that cycles through some other forms. The other forms are just single snapshots of some of the members of our research lab. There's no application running here. It's just the result view of the FormsVBT user interface builder.